Hello everyone, my name is Kanyaphak Pukyee.
And my name's Arisa Inai.
We are representing Kanchanapisek Wittayalai Phetchabun School, Thailand, our code EN001. And today we are going to present our study of the solar power hot air cloth dryer.
Due to global climate change, the weather conditions become more extreme. Sometimes there is an intense sunlight, and sometimes there are thunderstorms or tropical storms, resulting in rainy days without sunlight. This leads to several issues in daily life. For example, drying clothes during in rainy season become more difficult, as there is no reliable way to predict sunlight. Without the sunlight, the cloth fabric will dry slowly and sometimes cause a musty smell. Kanchanapisek Wittayalai Phetchabun School is a school with internal accommodation. Most of the students stay at the dormitory, and sometimes they have to wash their clothes manually. In rainy season, clothes are usually left drying at the dormitory during the school hours, which makes it impossible for students to collect the clothes if the rain comes. Therefore, our group had invented a solar-powered hot air cloth dryer based on the principle of solar cell, which is an electronic equipment that converts solar energy into electricity. Solar cells are made of semiconductors, which absorb solar energy and convert it into electrical energy. This dryer will reduce the drying time and effectively solve the issues mentioned previously. Objective 1. To invent a solar-powered hot air cloth dryer. 2. To study the efficiency of the dryer. Hypothesis: if a solar-powered hot air cloth dryer can convert solar energy into electricity, then the dryer will help drying fabric faster and more efficiently. Variable: the independent variable is the usage of the dryer. The dependent variable is the drying efficiently. The control variable are the fabric type, number of fabric, and the drying area. Expected benefits: 1. A decrease in the drying time. 2. The reduction of energy consumption from home. 3. Using solar panel technology to save time drying clothes.
Materials: a solar panel, screen, scrape tube, exhaust fan, screws, galvanized sheet, light bulb, power cord, battery, thermometer, inverter, and casters. Part 1. Cloth dryer design and implementation. 1. Prepare 4 pieces of 150 cm square tube and 8 pieces of 60 cm square tube. 2. Build a 150 cm square tube and a 60 cm square tube into a 150 x by 60 cm box. 3. Cast the galvanized sheet to the side to make the roof, left and right wall. 4. Measure 60 cm of square tube to make a rail in a solar power hot air dryer. 5. Attach the galvanized sheet to both the front and the back of the dryer. 6. Put the galvanized sheet under the dryer and attach the caster into a four corners. 7. Install the electrical system into the dryer and put 4 100-watt bulbs on the back of the fan. The second step is an experimental procedure in which the school sports shirts are washed and run out to dry in a solar powered hot air dryer. This is the front door of the solar hot air dryer. When opened, there is a cloth rail attached to the top of the solar hot air dryer. The cloth rail can hang up to 15 clothes. When putting the shirts into hang, we will turn on the switch of the solar hot air cloth dryer, which the switch is on the back of the machine. When the switch is turned on, the fans and lamp will turn on. The temperature inside the solar hot air dryer is then measured by placing a thermometer inside the solar hot air dryer to compare the inside and outside temperature. Then we close the door of the solar hot air dryer. This is the side of the solar hot air dryer. This is the circuit board and battery used to store energy. This is fan and bulb that are operating. We then observe the changes every 30 minutes to record the results and summarize them in graphs. This is graph showing the efficiency of the solar hot air dryer. The first graph is showing about drying the clothes under the shade without sunlight, and the second graph is to dry clothes with a solar hot dryer. The temperature for drying clothes in the shade without sunlight is 30 degrees Celsius, while the temperature for drying clothes in the solar hot air dryer is 37 degrees Celsius. It takes 180 minutes for clothes to dry in the shade without sunlight, but drying them in a solar-powered dryer takes only 90 minutes to dry. Summary of project results. From the experiment, the dryer dried the clothes faster than usual 1 hour and 30 minutes without the dryer. The heat from the light bulb and the air ventilation from the fan helped to speed up the drying process. Recommendations. Heat producing dryer will dry your clothes faster. Thank you for your attention.